All right, so we were looking at decimals yesterday. Now I'll go through some examples here, and yes, once again, we'll be using our place chart value here to help us with our understanding or our strategies to convert these. So the main thing here is to be able to convert decimals to fractions. Now, I'll see if there's a different way or a different approach to this. And I noticed that I didn't send out the notes for yesterday as well. So I'll be sure that immediately after this lesson, I'll send it out. Yesterday it was a bit hectic, so I didn't get a chance to send it out. Sorry, guys. So we'll take a few examples here from question number 7. I don't even know if it was for homework, that's okay. We'll do some of the questions now, okay? Now, could we break down our question once again? I'll grab this little section here. Let's go through our language strategies here and break down our question. So this process or this strategy here is actually called, there's a word for it, it's called transitivity or transitive analysis. So we're transferring our understanding, okay? So what here would be our process? If you want to type it into the chat, or if you want to unmute yourself and give a shout, feel free to.
Convert.
Convert, that is the process. Fantastic, Dion. What would our participants be?
Following decimal.
Yep, the following decimals. Now just, yes, so the following decimals, that's what we're looking at, but then how do we want to do it?
We have to convert it to fractions.
Yeah, to fractions. And then there's another, that's correct. In their simplest form is also a circumstance as well. Now, when we actually look at the question itself, is that a process, a participant, or a circumstance?
Participant.
That's a participant. That's correct, Dion. Fantastic. Okay. So if we have a look at this decimal here, 0.31, I'll pull up this place chart value once again. So one, you can use your place chart value to help you answer these questions here. You'll be able to see that the 0.31, if you use your place chart value and you write your value there, there's a decimal point, and we've got 3.1. That's what I just wrote at the bottom there. You can see we go to our hundreds, okay? So when we look at these values here, it's important for us to understand what this hundreds, tens, ones, tenths, hundredths, and thousands mean. So what I'm doing on top of these values here, and we might spend a bit of time today to break down and just write this out in a different order or a different way, so it makes life easier for us, okay? So another way that you can do this, so you can see that it's 0.31 and the lowest column there is hundredths, so we would divide by 100. But here's another way to look at it. You ask yourself, how many decimal places do we go after? How many decimal places, or how many place values do we have after the decimal point? What would the answer here be? How many place values do we have after the decimal point?
Oh, look. 10.
2, that's correct. So we have 2 decimal points after, oh, decimal or place values, sorry. We have 2 place values after the decimal point. So you can see we've got 1 number and 2 numbers. This here represents the number of zeros that we want to have. So if we have a look, yes, you can, Ezra. Sorry, I didn't see your message. The number of place values tell us how many zeros we need. I'll just put in a bracket here, zeros we need. So this tells us we need 2 zeros. So what we do is we look at the number without the decimal point now. And so we would see 031, but we would just count that as a 31, okay? And we would divide that by 1, and we've got to add 2 zeros. So 31 over 100. That's it. Can we simplify this?
Maybe.
Looking at the 31 and the 100 and the 100 there, is there any number that would go into it?
No.
Unfortunately not. Yeah, so what we're going to do is we're going to conclude that that is the most simplest form. That is done there. It is already in the simplest form. Okay, so I'll leave that place value chart there. And we'll try another question. Now we have this strategy here. We can go through and try this. We'll do B as well. And I know for some of you who have done the homework, like Dion, you would already know how to do this. So, but just follow along anyway. That'll be great. So what do we see here? How many place values do we see after that decimal point?
3.
So how many zeros do we need?
3.
Yep. So we need 3 zeros. So 0.537 is equal to, what's the number going to be in the numerator? What's the number going to be in the numerator?
537.
537, that's correct, Angelina. And what's the number going to be at the bottom?
1000.
1000, because we need 3 zeros, okay? 1, 2, 3. You can see there. And I'm just going to write the lines here, 1, 2, 3, so you can make that connection that the 3 place values will mean 3 zeros. And thank you, Armin, for typing in the chat as well. I might just pull this chat here so it's directly in front of my face. Yes. Try 7C. So once you start getting the gist of this or understanding what happens, we can just try a few more. I just wanted to ask you, do you think we can simplify this?
No. Yes.
No. What can we simplify it by?
The
Yes,
5.
no. Can we divide it by 5? Give me a second. Riley. Hello. Hold on. He's connecting. Abdul. You're present. Just seeing if there's anyone else new. Oh, Mark Riley Johnson present. Hey Riley, if you could just follow along, what we're doing is we're converting decimals to fractions, okay? So if you can follow along, I'll send everyone the notes at the end of this lesson so you can follow along. Thanks. So if you have a calculator, yeah, if you type it in 500, like this green calculator in particular, by the way, if you type 537 divided by 1000, it's a way for you to check. And I'm just checking here, it can't be simplified. So we leave that as our final answer. That's the simplest form, okay? Let's check this one out. How many zeros do we have?
3.
3 zeros, fantastic. So we take this number, 0.815. We will divide it by 1 with 3 zeros. And our number at the top will be
815.
315, fantastic. Thank you, Dion. Thank you, Ahmed, for typing in the chat. Now, can we simplify this?
Yes.
Yep.
Yeah.
What's the clue here?
5 and 0.
5 at the end.
Yeah, the 5 at the end and the 0 at the end as well. So what is this divisible by?
5.
5, fantastic. So remember, when we're simplifying numbers or simplifying fractions, we're trying to divide it. So the numbers at the top and the bottom get smaller, but this proportion here stays the same. So they're still equivalent fractions. Remember that word equivalent? They're the same or equal in amount, but it's just that the numbers are more simple, more basic, okay? So let's revise this stuff about long division, yeah? Let's see. Who would like to volunteer for this first one here? Don't worry, we'll double check and we'll walk through it together as well.
How much times does 5 go into 8?
Yep. How many times is that, Mohammed?
Once.
Once, okay. And how much do we have left over till we get to 8?
And then you put the 3 next to the 1.
Yep. So 5 times 1 is 5. To get to 8, you have 3. So what's your number now?
31.
31, okay. And how many times does 5 go into 31?
6.
6. 5 times 6 is?
30.
30. And how much to get to 31?
6 times.
Well, we're at 30 now. So to get to 31, how many units is that?
1.
Just 1, that's correct. And we carry that 1 to the next bit. We've got 15 now. What's 15 divided by 5?
3.
3, fantastic. And there's nothing left over because 5 times 3 is exactly 15, okay?
Yeah.
So that means that our top number now becomes 15. That's great. I'll just shuffle this across here. Our numerator is 163 And what's 1,000? 1,000. Whoops, I should space out the numbers a bit. 1,000 divided by 5. Can someone else give it a try? Angelina, I think you unmuted yourself before. That's correct, Ahmed. Let's have a look here. We've got 1, right? But 1's too small for the 5. So 5 can't go into 1, but 5 can go into 10. Yeah, it goes into 10 twice. So 2 times 5 is 10. Is there anything left over? Nope. So then we just go to the next 0. And since the thing about 0 is 0 divided by 5 is 0. We go to the next one, 0 divided by 5 is 0 again. So we end up with 200 in the denominator. Now, can we simplify this any further, you reckon?
No.
Nope, doesn't look like we can, yeah? So that's our simplest form, that's it. Okay. I just want to give you a shot at, let's have a look at 7F here. Just as a random one. Remember, I just want you to attempt at least 3 or 4 questions from this section here.
Mister,
Yes, Idris?
if there's a whole number but in front of the decimal point, do we just ignore that?
Well, we'll see, right? We'll see. So, well, let's follow the strategy that we did. We counted, the first thing that we did was we counted how many zeros we had after the decimal place, yeah? After the decimal point. So how many place values do we have? We have 2, yeah? So there's 2 spaces there, so we need 2 zeros when we divide it. Now, when we go to write our number in the numerator for our fraction, we just ignore the decimal point. So what's our number at the top going to be?
822.
That's correct. Fantastic. To Angelina and to Idris as well. And what's our number going to be at the bottom? How many zeros should we have?
1,000.
1,000?
100.
100. Yeah, we said that we needed 2 zeros, yeah?
Can it be simplified?
Yeah, can this be simplified? What do you notice about the numbers?
Yes, it can.
The open.
Okay, what's the easiest number that you can divide it by?
2.
2, why is that?
Because both of them go into 2.
Yep, both of them can be divided by 2. What told you that? What gave you the clue?
The 2 at the end of 822.
Yeah, and what about the 0? Does that give a clue as well?
Yeah.
Yeah, what do we call these numbers here? 2, 4, 6, 8, 10.
Even.
Even, that's correct. So if it ends with an even number, then we know it can be divided by 2. So what's 822 divided by 2? Let's try not to write that out. How many times does 2 go into 8?
4.
4, fantastic.
407.
Nothing left over? That's correct. How many times does 2 go into 2?
1.
1. And how many times does 2 go into 2?
1.
1. So we end up with 411. Fantastic. Let's try dividing 100 by 2. We can just use logic.
50.
Yeah, that's it. Can we simplify this any further?
No.
No.
So would you be happy to say that this is the simplest form?
No.
No.
Well, you can try typing it in your calculator to double check, yeah? If you type it into your calculator, I'll show you. Let's see if I can, oh, there we go. I don't know if you guys can see my screen there, but it says 8 point, oh God,
Equals
8.22
Yeah.
equals 411 over 50. Okay. So it can't be simplified any further, because if it did, the calculator would have automatically done it for us. So this here is our simplest form. Okay. So would you guys like to try another one, or would you like to move on? I'll give you guys the option. Just put a thumbs up on the reaction if you're happy to move on. And if you're not happy to move on, put a, I don't know, a cry, an open mouth or something. Yeah, you guys are happy to move on? All right, fantastic. Let us do that. So these notes here will be sent through to you as soon as our lesson finishes, because I have some time afterwards, so I'll do that immediately. Whereas yesterday I was like, I had back-to-back classes and I had to chase everything up as well. Okay, so thanks for that, guys. Now, the next skill that we need to do, if we know how to convert decimals to fractions now, guess what? We also need to know how to do the opposite. So we're starting with a fraction now, and we actually want to figure out how to find the decimal, okay? Now let's have a look here. Still gotta grab this. So what did you notice about the denominator? The denominator is always a 10, a 100, a 1000, okay? So what that tells us is that we should try to get it into a 100 or anything with what we call a base of 10, yeah? So this is what we call this number here at the bottom, when it's a 1, a 10, a 100, a 1000, we call that a base of 10. Okay. So this will give us a clue when it comes to a more difficult question like 9 over 25. I'll show you how, I'm not going to say easy. Once you understand it, then it will be easy, okay? So when it comes to converting fractions to decimals, what you need to look at is how many zeros you have, okay? How many zeros do you have? In this particular question or this particular example, the answer is you have 2 zeros. So what this means is that we should take our number in the numerator. Right now that number is 239, and then decimal point is at the very end, okay? What we're going to do with that divided by 100 is we move that to the left or the right. Do you reckon we should move it to the left or the right?
Right.
To the right? Okay, let's see if we move it to the right. How many points, how many spaces should we move it to the right?
No, left.
All right. So we got some people saying right, some people saying left. Let's explore this. Okay. So let's say we move it to the right by the amount of zeros that we have, by 2 zeros. So we got 1 space, 2 space. So our decimal point is over here now. Let's erase this. What do we fill in with these gaps here?
Zeros.
Zeros. So is 23,900 the same as this fraction here? Or does that seem a bit strange?
Strange.
It's a bit strange, yeah? Because when we divide it, shouldn't it be a smaller number?
Yeah.
Yeah, especially if the number at the top is, yeah, especially when the number at the bottom, we have a number at the bottom, it should become a bit smaller, yeah? So in that case, then, we don't want to move it to the right. We actually want to move it to the left, to the left. Yep, so when we divide by 100, this tells us to move it to the left. So let me write a note for this. All right, 1 divided by 100. Dividing by 100 tells us to move the decimal point to the left. Okay. So what we're going to do, we're going to move that to the left. 1, 2. So where's our decimal point now? $239 over 100 is equal to 2.39. Okay, so there's our new decimal point. And that's it. That's our decimal. It's in decimal form now.
We move it twice because it's equivalent to 2 zeros.
That's correct. We have a look at the number of zeros on that bottom number, and then that tells us how many points we have to move it.
So all we do is move the decimal point to the left of how many zeros there are, and is that your decimal?
That's correct.
Okay.
So that's one way to do it. Okay. But I'll show you that this strategy here might not always work. Okay. But for this next question here, it will work. We have 9 over 25. So sorry, I forgot to do our transitivity. Just before we start on that question, let's break down, and because I assumed that, you know, I just told you what we need to do, but just remember, when we look at a number, we need to know what we need to do with it. Okay, so what are we doing to this 9 over 25? What's the process? What are we doing to it? Once again, we need to convert the following fractions
to decimal.
Yep, and that following fraction is that 9 over 25. And how do we want to do it? We want to change it to a decimal. That's the circumstance there. Okay. All right. So let's have a look at this 9/25 now. My question to you is the denominator, listen carefully, is the denominator a base of 10?
No.
No. If it's a base of 10, the bottom number should be,
0.
well, it should have zeros on it. It should be 1, 10, 100, 1000, etc., etc. Yeah? Which whole number, which base do you reckon is a good one to have? What can we change this 25 to? Can we change it to a 1? Can we change it to a 10 or 100 or 1000? So some of you started with saying 10, but then Idris, you said 100. Why do you think that's so?
Because Mister, if you go to 10, then you'd be making the denominator smaller, and the 9 wouldn't be going anywhere.
Yeah, but it's hard to make the 9 even smaller. Yeah.
You have to like divide 9 by.
Yeah, to make the numbers smaller, you need to divide. That's right. Yeah, but it's just too hard, right?
Yeah.
So instead of doing that, we'll make it 100. So what do we need to multiply the top and the bottom by? What do you think we need to multiply this 25 by to get to 100?
4.
4?
Yeah.
Yep. So if we look at our 25, 25, if you go into the next one, you add another 25, that's 50. If you add another 25, that's 70. If you add another 25, that's 100. So that's, you see that's 1, 2, 3, 4 times. So if you go 25 times 4, what you do to the bottom, you do to the top. And that's equal to 36 over 100. Okay. And how should we play around with this number here? What would this be as a decimal?
Zero.
As a decimal.
36.
Yep. Yeah, Angelina, did you want to give this one a try? You're right, Mohammed. Yep. But give this one a try.
Is it 36?
All right.
And then a dot and then 2 zeros.
Yep. A dot there. And then how many points do we have to move that decimal point?
2?
By 2, because why is that?
Because there's 2 zeros on 100.
That's correct. Fantastic. So I'm going to move that. And there's our new decimal point. All right. So this is part of our working out here. That's our working out. It's not equal to that just yet. So I'm just doing it on the side here. So if we have this, in our next line, we should write 0.36, yeah? Or 0.36. Is this how you usually see decimals?
Yes.
No.
Angelina, what do you think? What do you think we can put? Do you reckon our answer is 0.36?
You put a 0?
You put, where are you putting a 0?
Right where you put the dot. I mean left.
On the left. Fantastic. So it's 0.36. Awesome. That's it. Excellent. And that's our final answer. That's the decimal. Okay. So I want you to, what we'll do now is we'll grab these questions here. And I want you to try these ones if you haven't already. Dion, is this making it a bit easier for you to understand? Because you self-taught yourself, yeah? You self-learned this. How are you feeling about it? Has it kind of changed the way you see it, or Were you already, yeah? Was it improve it, or is it just add on to it, or did you already know how to do this?
It improves.
Okay, cool. How were you doing it beforehand? Could you explain it? Yeah. Oh, is it the same way? Now you just feel more confident with it, yeah?
Yeah.
Awesome. Now that's it. Fantastic. So maybe I'll select a few random questions here. You guys can try this in your book first. And look, afterwards, when you do homework, if you want to do more questions for more practice, because it's like, oh, damn, I get this and it works. If you want to go back and you want to do more questions, by all means, do it. It's more practice for you. It's once you get it, it's actually really, might sound a bit nerdy of me, but it's really fun to do once you understand how to do it. Yeah. So, and then you start to, it's like, oh, I can do this. I can do it faster. And then you do it a bit faster.
Mister, what's a PD?
A PD,
Yeah.
in what context? What kind of scenario are you talking about? Where did you see PD?
I don't know. My mom was on the phone talking about my brothers or something. I don't know.
Your brother's PD?
I don't get it. I was confused.
Yeah, I'm also confused. Once you get really confident with this, you can just look at the number at the top really, and you could go, okay, I just need to move this 3 to the left. I just need to move the decimal point 3 to the left. So I've got 674, 1, 2, 3. There's the decimal point. Get rid of that line there. And then at the front, if there's nothing, then you just fill it in with a 0. If you want to show a bit of working out, that's really cool as well. Okay, so there it is. How did you guys go with that? Are you still writing it down? Just give a thumbs up if it's good. If it's not, then like do a surprise face or something. Like a wow. Sweet. Man, fantastic. Coda? Riley? Thumbs up, thumbs down? Ahmed? Angelina? Angelina, thumbs up, fantastic. Coda, awesome. Riley, anything? You can type to me. All right, so that's all right. Cool.
Mr.
Yes, Mohammed.
You see for number F.
Yes. 8F.
Number F.
Number. Yes. I see 8F.
Yeah.
A question there.
You see for all the other ones how you put the 0, like 17, 0,
The working out section, yeah?
yeah, 118, 0. Why didn't you do that for number F?
I kind of did a shortcut, but yeah, I'll write down the working out for it now, actually.
Oh.
Yeah, so here's the working out. Or if you can't be bothered writing working out, just write working would be fine. So 674, decimal points at the end. We want 3 zeros. We have 3 zeros, so we want to move it 3 to the left. 1, 2, 3. Here's our decimal point. And you can see that there, we fill it at the front number with a 0. Okay, cool.
Yeah.
Awesome. Let's have a look at this next one here, because that's like our second example that we did here, yeah? So what I might do is I might copy this and I might paste it down just so you can see how we did our working out for our example question. So you guys don't have to memorize, like try to remember what we wrote at the top. Oh, no. All right. So remember, the goal was to make it a 100 on the bottom by multiplying it, okay? So let me write that out. Multiply the denominator. Remember the denominator, D for down, which means the number at the bottom, to get to 100, okay? It's not always 100, but we try to, yeah? And when we run into a roadblock, when we run into a problem, then we'll try we'll figure out a different way to do it. But for now, this one seems to work. So we've got 3 over 25. What can we do to the 25 to get it to 100?
Times it by 4.
Yeah, so notice this example here, we multiplied the 25 by 4. So let's do the same here. Multiply by 4. What we do to the bottom, we
Do it to the bottom. I'm in the top.
the top. Yep, that's the one. Thank you. And we can figure out what that value is. 12 over 100. 3 times 4 is 12. 25 times 4 is 100. Oh, and now it just becomes like the question we just did before. So we can go off to a side and we can do our working. We had 12 with the decimal point. Because we have 2 zeros, we move it 2 spaces to the left. Put the decimal place there at the front. Since there's no number, we fill it in with a 0. So therefore, our answer is 0.12. Tick. That's our decimal. Okay. There it is. Now just get rid of this here. So just have a bit more space here to play around with. I think this here is the main goal, yeah, for now. Multiply the denominator to get to 100. All right, I want you to try it for 7 over 20. I want you to try it for 5 over 2. We just might spend the rest of the lesson here trying to convert these decimals, these fractions into decimals, okay? You know what, let's actually see if we can do all of them. Well, that'll be the challenge, yeah? I'm gonna do 9e down here. Nine F. By the way, 9e and 9f, we're gonna have a discussion about those ones, okay? I'm gonna have a talk about those. Because they're a bit special. All right, guys, go ahead. Try those ones. And I think we'll skip 17, we'll go to H, sorry. 29 over 125. Bear with me for a second. Here over 8, and this one here as well, we'll have a chat about that. But try the first 4. In case if you want to see which questions we've done, or which questions we're doing, A, B, C, D, E, F, and H. We skip the G because it's very similar to our first question. All right, go for it.
Mister, do you always times it by 4?
Well, have a look at part B, yeah? What's the denominator in part B?
20.
20, right. So how do we get that to 100? What do we have to times it by? Have a think.
5.
Yeah, 20 times 5, yeah? So we'll write that down. Times the bottom by 5, times the top by 5. 7 times 5. Angelina, what's that?
35.
35, very nice. And 20 times 5?
20 times 5, wait. 100.
100, perfect. And then you can do your decimal stuff.
All right.
Sweet,
Thanks.
all you.
Mister, you know, if the denominator is under 10,
Mm-hmm.
do we have to times it to get to 10?
Yeah, that would be a fantastic idea, actually.
Okay.
Instead of going to 100, you can go to 10. Why is that?
Because it's the closest.
The closest, what was that phrase?
Yeah.
It had to be a base of 10, yeah? We don't have to always multiply it to get it to 100. Yeah, so this one here, get it to 10.
5.
That's right.
And then the top one by 5.
That's correct. So we're starting to hit some interesting questions here, yeah? So get this one to a 10. What you do to the bottom, you do to the top. Five times 5 is 25. 2 times 5 is 10. We're going to change that fraction now by doing a bit of working out on the side. Got 25 point, and we move our decimal place 1 to the left because there's 1 0.
Mister, how about for the next one, D? You can't times anything by 4 to get to 10.
Yes, that is correct. And so this is why we'll have a discussion about this one, because now it doesn't seem to work anymore, yeah? The way that we've been doing it so far has served us very well, but now it's come to an end. So we need to change up our strategy here. And I could have gotten you to do this from the start, but you know, getting us to work with that base of 10 there, when it's over 10 or if it's over 100, it's a lot easier for us to work with. But when it comes to this now, there seems to be a bit of a problem, yeah? Like you said, Mohammed, we can't multiply 4 by any whole number to get to the number 10, which is a bit of a problem here. So what we can do though, see that 7 over 4, what's another way of saying this over here? What's that symbol related to? Is it plus, minus, times, divide? Which one is it?
Division.
Yeah, it's division, yeah? So
Isn't division sign, Mr. Like the 2 dots in the line? Wouldn't that be fraction numerator? What's the line called?
and the denominator, yeah? That's correct, 100% correct. Yeah, so you can see there that we've got a bit of a problem now. So what we can do here is it's suggesting us to do division. Okay, so let's go over to the sign. We'll do a bit of working here. Let's see if we can come up with something. What number goes on the outside? What number goes on the outside here?
7.
Ooh, Maluka, fantastic. Mohammed, 50-50 chance. It's not the 7. It's the 4. That's correct. So the denominator goes on the outside, okay? The numerator, which is the 7, goes on the inside. Now, note that this 7 is 7 point, okay? It's 7.0000, and it keeps on going forever and ever. There's an infinite amount, infinity, yeah? It doesn't ever end with the number 0, but we just can't be bothered writing all of those out. So we might write a few of them just to see where it goes, okay? We'll start off with 2 of them. And then we do division. Now, see that decimal point there? Just be like, okay, we're cool with this. Don't worry about that decimal point, but I'm just gonna put it up here, yeah? Just for the sake of it. Just right on top of it. And we divide it just how we would normally. So how many times does 4 go into 7?
2.
2? 2 times 4
Is it? Oh wait, no. Yeah. But
2
I'll
times 4 is 8, yeah? Is
Yeah,
that over
but-
or is it under?
over, but
That's over. We want it to be,
under.
yeah, we want it to be under. That's right. So should we go 4 times 2? Or 4 times
1.
4 times 1? Okay. So 4 times 1 is 4. And now we can get to 7, yeah? So how much do you have left over?
6.
Is it 6? What's 7? How much do you have to count from 4 to get to 7? Yep. I heard a 3 there. Yeah. So we write the 3 there. Okay, we carry the 3. Again, just ignore this. Imagine it's not even there, yeah? So how much does 4 go into 30? How many times?
8.
8? So 4 times 8 is 32. Is that over or is it under?
Over.
That's over. So we don't want to go 4 times 8. We want to go 4 times
6.
7.
What's the number? But yeah, the number below 8 is 7. Yeah. So what's 20? What's 4 times 7?
28.
28. How much do we need to get to 30?
2.
2. From 28 to get to 30, 29, 30. So we write the 2 there. Our number is 20 now. How many times does 4 go into 20?
5.
5. Do we have anything left over? 4 times 5 is 20, yeah? From 20 to get to 20, there's nothing. It's already smack bang onto the 20 there. So there's actually nothing left over. So if we did have anything left over though, then we can continue writing some zeros and then we could, continue on and, do what we need to do. But that's right. And we could keep going. But since it was 0, that's it. We're done. We can write an extra 0 here. And because there was nothing left over, 0 divided by 4, how many times does 4 go into 0? It's 0 times. So that's our cutoff point. That's it. We can stop there. Now see the number at the top there? That there is our decimal. The whole number at the top. So this means that 7 over 4 is equal to 1.75. You can add in that 0 if you want, but you don't need to because it's at the end, yeah? And that there is our decimal, guys. Interesting?
Mister, I got a question.
Yes.
You see, for the top one, not the top one. Yeah,
For 9C?
yeah. If it's a base of 10, does a whole number have to be in front of a decimal?
Well, how many spaces are you moving the decimal place to the right, to the left, sorry?
Oh, 1.
1. And you can see that's why I wrote here, over in the working out section, I wrote 1, 0. And that's why I've only moved it 1 to the left.
Okay.
Cool?
Yep.
Now this one here, what do you notice here? We've been doing, with fractions and decimals, we've been doing a lot of division, yeah? And I noticed that almost every single one of you guys have improved so much. At the start of this year, we were really struggling with division and multiplication, but now you guys are improving so much because what did you notice? That these numbers come up all the time. We're not seeing anything new here. It's just how we're using it. The numbers come back and forth, but we're just dividing it by different numbers, and we're applying the same skill, really. So when we get to this question here, 9E, again, this one here is a bit challenging, yeah? Just remember that it's the same as 11 divided by 40. Yeah. Where's the decimal point on the 11?
It's in front of it.
At the
Yep.
end.
It's at the end of the 11 there.
Yeah.
And what numbers come after the 11?
The decimals.
Yeah, what number though?
0.
Yeah, you can fill it out with an infinite amount of zeros, but let's start off with just 2 of them for now. Okay. Now we actually have 40, which is a bit scary, yeah? Now, that 40 there seems a bit big, right? But let's should we try to work with it, or should we cut it down? Do you want to try cut it down?
Yeah, but how?
Let's try to move, see that 40, that 0 at the end there seems really like annoying, yeah? We could make it a 4. Yep, what's your suggestion?
Nothing.
You sure? How can we
Yeah.
turn that 4, how can we turn this 40 into a 4?
You take
Put
it out
the
the
0 at the end of the zeros.
Yeah, there's a decimal point at the end of the 0 and the end of the 11. Can't we move that decimal point to the left by 1? Can we do that?
Yeah, you can make it 4 and then times it. I mean, divide whatever it's called.
Yeah. But then if we move the decimal point here to the left by 1, what do we have to do to the top?
I don't know.
What we do to the bottom,
Do it by 1.
we do to the top as well. So what's the number at the top going to become now? It's not 11 anymore. We move the decimal place 1 to the left.
It's
It's 1.
It's 1 point.
1.
1.1. And what's the bottom number becoming?
4.0.
Yeah, which is just
4.
4. So which one do you reckon is easier to do? Let's write it out and compare. We can either do 11 divided by 40, or 1.1 divided by 4. Which one's easier?
The bottom one.
The bottom one, yeah. So just remember that these two are the same though, yeah? It's just that the decimal point has been moved over a bit by 1 place value, okay? We can do that. That's a trick there for you to use. And we know that at the end after this, it's just a bunch of zeros, yeah? See this decimal place? Where should we put it on the top line? Should we put it over here?
No.
On top of it.
Directly on top of it. Fantastic. So let's actually start going through this now. What's 1 divided by 4? How many times does 4 go into 1?
1.
4 times 1 is 4. Is that over or under?
Over.
That's over, yeah? So instead of going 4 times 1, we should go 4 times down 1, which is 4 times 0. Yeah, and how much did you have left over?
0.
From 0 to 1, that's 1 left over, isn't it?
Yes.
So carry that 1. And that's why we go for 11 divided by 4. Okay. So how many times does 4 go into 11?
Two times.
Twice.
2 times? Twice? 4 times 2 is
8.
4 times 2 is 8. And how much remainder?
3.
3. That's correct. So we'll put a 3 here. How many times does 4 go into 30?
7. Remainder
7.
2.
7. Yep. So 4 times 7 is 28. 28 to get to 30. That's a remainder of 2. That's correct. Fantastic. Now what's 4? How many times does 4 go into 20?
5.
5.
5 times. Any remainder?
No.
No remainder. So that's it. That's all. No remainder. So we can cut off right there. So what's our answer then? What's 11 over 40 equal to as a decimal?
Uh,
0.275.
That's correct. Our decimal is the answer at the top, or what we call the quotient. Yeah. This position up here is called the quotient. And that's our decimal up here. Okay. So that there is our decimal. Okay. So what I want you to do is I want you to give this a try. And this one here, unfortunately, we have to keep that as that. I just want to see if we can make that, see how many times you can times 125 to get to 1,000, if that's possible. Yeah, that's possible. So this one here will be a challenge question to see how many times you have to multiply 125 to get to 1,000. Okay. We can make this 1,000 by multiplying
8 by 8.
Aha, that's correct. Okay, so I want you to give that one a try for homework, and I want you to give this a try for homework as well, okay? So fantastic job, guys. Thanks so much for tuning in, and give this a try for your homework.
okay, bye, Mr. Sia.
Bye,
All right, thank you. See ya, see ya.
Bye.
Bye-bye. I'll send the notes now. Take care.